Exponential functions. A simple exponential function is a function of the form y is equal to b to the power x, where x is a real number. The b here, the constant, must be more than 0 and should not be 1. There's no actual problem with it being 1, it just doesn't give us any features, it just becomes a straight horizontal line. So if b is not equal to 1, then we get a proper exponential. Let's consider, as an example, y equals 2 to the power x. And we're just going to use a table of values. Now, the easiest one to compute straight away is 2 to the power 0, because we know that that will be 1. 2 to the power 1 is obviously 2. 2 to the power 2, 2 times 2 is 4. And 2 to the power 3 is 8. And note that these are doubling every time we go up. Now 2 to the negative 1, we know from our index laws, is 1 over 2, so that's a half. But note how we've still got this doubling as we go up. So rather than thinking about index laws, I can just half 2 and then half a quarter. And so we have a table of values from which we can produce a graph. So let's bring in some graph paper and start plotting. So I'm going to start with the x is 0, y is 1, so that's going to go at 0, 1 here. And then we have 1, 2, and 2, 4, and 3, 8, like so. If we follow the doubling, we're also going to get 4, 16. And then going backwards, we've got negative 1, a half, and negative 2, a quarter, and they become very difficult to draw. So let's actually just bring in the graph, and it looks like this. So let's look at some features that we should know. The y-axis intercept is at 0, 1. That's the same whether it's 2 to the x, like this one is, or 3 to the x, 4 to the x, because anything to the power 0 is 1. The negative x-axis, that's the part of the x-axis that takes the negative numbers, is an asymptote. Now, an asymptote is a line that a curve gets closer and closer and closer to, but never reaches. So this line, no matter how far we go along, is always going to be a bit above the x-axis. Think about the values we have here, half, quarter, eighth. Next one will be a 16th and a 1 over 32 and so on. They're all positive numbers. Now, in the previous example on solving equations, we came up with a 3 to the x was a negative number, and that's why that's not possible. This curve will never dip below the x-axis. Now let's consider the domain. The domain is the set of input or x values for which the curve exists. And there's no problem here. X can be any value whatsoever, so this graph will go on infinitely this way and infinitely in this direction. The range is the set of y values that the curve can take. So that's when we're looking across ways. And we can see there's no curve down here below the x-axis. So the range is that y does take real values, but only values that are greater than 0. Now, what follows on the OneNote are some Geogebra apps where you can play with various transformations of the exponential graph. And by doing that, you should increase your understanding of what an exponential graph is and what different features it can take if we change certain things about it.